guys, welcome back for Unit 3, Lesson 6, Even and Odd Functions. We're going to start talking about even functions. They're functions that return the same expression for both x and negative x. So for even functions, f of negative x is the same as f of x. Its table of values will have symmetric values, which means that the negative and positive x values will generate the same f of x values. So if you have negative 2 and positive 2, the f of x values are both 4. Okay? Remember, these are x and this is y on the coordinate plane. So at negative 2 and positive 2, they're both going to cross at 4 on the y-axis. Okay? At negative 1 and positive 1, they're both going to cross at 1. Okay? So it's always going to be a parabola shape. Okay? Identifying even functions. Characteristics of even functions are when you substitute in negative x for x, the outputs of the function remain the same, which is back here. Whether I'm using negative 2 or 2, my answer is 4. Whether I'm using negative 1 or 1, my answer is 0. It doesn't matter if my x value is negative or positive, my y value or f of x value is the same. When represented on a table, the f of x and f of negative x values are identical, which is just saying here the same. If this is negative or positive, this value is going to be the same. It's still 4 regardless of what's going on with x. When represented on a graph, the reflection is symmetric about the y-axis. So if I fold it on the y-axis, this line is going to line up exactly with this line. It doesn't really look like it here. It looks a little off. But that's what it means, is that it's the y-axis is the point where you can fold the paper and get an exact copy. It has to be the y-axis. It can't be anywhere else. So make sure that these get put into your notes. Here's example 1. Explain why the following graph, f of x is equal to x squared plus x, is not an even function. Okay, now I'm going to blow this up so that you can see this a little bit more clearly. The reason this one is not an even function is because of where this vertex is, this low point or high point, the point where you would fold. If I fold this in half, it's not sitting on the y-axis. It's sitting at like negative 0.5, okay? That doesn't work. It has to be the y-axis every single time. The graph is not symmetrical about the y-axis. The parabola has symmetry. You can fold it in half and have it match, but you can't fold it on the y-axis and have it match. Therefore, the function is not even, and you can see that here. If I go negative 1 and 1, they do not have the same f of x values. At negative 1, I'm sitting at 0. At positive 1, I'm sitting at 2. I can't fold it on this y-axis. I can't take negative and positive values that match. At negative 2 and positive 2, I have two different f of x or y values. This is not an even function, or is that what we're calling them? Yeah, functions. Okay. Example number 2. Based on the table, which function or functions look the same when their graphs are reflected over the y-axis? This is just another way of saying which one of these are even. It can have more than one correct answer. Okay, so if we stop and look at negative 2 and 2, they both have 5. That's a good sign. At negative 1 and 1, they both have 2. Okay, so far this one works. At negative 4 and positive 4, they have 64 and negative 64. That doesn't work. At negative 2 and positive 2, they have 8 and negative 8. That doesn't work. And then we have 0 and 0. At negative 3 and 3, we have 11 and positive. We've got both 11s. That works. Negative 1 and 1, both 3. That works. Okay. So they said that this one is correct. I disagree because they said they need to match exactly, and you can't have these negatives in here. So this one should be crossed out as well. This is the only one that is an even function. What part of the graph does an even function reflect about? So it's also another way of thinking that where would the paper fold in half to get that perfect reflection? Okay. The answer is the y-axis. Okay, we're only reflecting side to side across the y-axis, no other direction. This is important. It should be in your notes. Here's question 1. This one's all you. Identify which graph is an even function. Okay. Remember, it is reflecting only over the y-axis. If this reflected over the y-axis, then it would look like this. It would come up like this. And it doesn't because it's not a parabola. It reflected over the y and then over the x. So it's not this one. It has to be this one. Okay? Graph A is even because it looks the same when it is reflected over the y-axis. Here's question 2. This one's all you. Does the function f of x equals x cubed minus 3 represent an even function? So there's 2 ways you can figure this out. You can either go on GeoGebra and make a graph, or you can make a table filled with values and figure it out that way. Okay? You can do either way. Go ahead and solve it and then come back and we'll go over it. So the way they solved it is they said it does not represent an even function because if we take this and we put negative in for each of the x's, so f, this becomes a negative x, and then we have a negative x here, cubed minus 3, okay? So they didn't do a table, they're just using the formula here. I'll show you how you can do it with a table too. Okay, negative times a negative is a positive, times a negative, it still stays a negative. So this becomes negative x cubed. This just drops down, so it's minus 3. So is this formula right here the same as this formula? No, because this has a positive x cubed and this has a negative x cubed. So they are not equal to each other. That means that this is not an even formula. Okay, an even, what are we calling it? An even function. I knew it started with an F. Okay, if this made sense to you, you can just go ahead and move on. But now I'm going to go back and show you how I would figure this out in a way that makes sense to me. I would do it with a table, okay? So if I have my table, we're going to say this is x and this is f of x, okay? And I'm just going to pick values for x. So I'm going to say -1, 0, and 1. And what this should do for us is this should show that this number should be the same and this number should be the same if it's an even one. We already decided that it's not because this says it's not, but let's try it. So if we have f of x is going to be equal to -1, let me get my little equals in there, minus 3, -1 times -1 is +1 times -1 is -1. -1 minus 3 becomes -4. So this one would be a -4, okay? We're not going to bother solving for 0 because we don't need it to be able to find out whether or not this is an even function. Let's try solving for +1. So we have f of x is equal to +1 cubed minus 3, which would give us 1 times 1 is 1, 1 times 1 is 1, 1 minus 3, and that's going to give us -2. So you can see right here, by using a chart, which makes more sense to my brain, that this does not work. This is not an even function, okay? So there's 2 separate ways to do that. You could also graph it on GeoGebra, and you would see that it does not fall over the y-axis, wherever the parabola is. If it's -3, it's going to be over this direction. It's not over the y-axis. So you can't fold it in half over the y-axis. 3 different ways to be like, nope, not an even function, okay? Practice question number 1. This is at the end of the lesson, so just write your answer down on a piece of paper and you can enter it later when you come back. Use the graph to determine if the function f of x is equal to x squared plus 5 is an even function. It's either yes or no. Okay, so pause the video, figure it out, come back. Okay, so again, maybe it's just me today, but it feels like everything's getting stretched this way. So it doesn't look perfect to me. So I'm going to double check by checking points. So if we come over here to x equals 1, we're at 6. And if we come to x equals -1, we're still at 6. So that one worked. Let's come up here to 2. We're at 9, -2. We're at 9. So yes, this is an even function. So the correct answer is yes or 1, however you want to determine that. Okay, let's go on to practice question number 2. Using the graph, determine if the function is an even function. Select the correct option. Your answers are either 1 or 2. So pause the video, figure it out, come back. Okay, you have to fold the paper right there. And if you fold the paper, then our graph is going to look like, I can't draw, like this, and then it's going to come up in a V. Okay, so this is not an even function because it's not mirrored across the y-axis. Has to be y-axis, can't be anywhere else. Here's practice question 3. If f of x is an even function, what is the value in the missing entry on the table right here? Okay, so pause the video, figure it out, come back. So we know that each x value, whether it's positive or negative, has to have the same y value. So it wants to know what the value is going to be for 1. Well, for -1, the value is -2. So this has to be also -2. Everything stays exactly the same, okay? No sign flipping, no math, just copy it straight over. This is quick check at the end of the lesson. I won't give you the answer, but I'll tell you how to figure it out. Identify the graph of an even function from the following choices. So remember, it's folding the paper in half and the lines match up perfectly and it has to fold in a very specific place. So remember where it folds and which one of these, the 2 lines, will match exactly. Okay. Quick check question number 2. Which table provides points for an even function? So again, if your x value is 2 and your x value is 2, then your y value should be the same. If it's 1 and 1, then the y value should be the same, so you have to figure out which of these is correct. Okay. Quick check question number 3. If f of x is an even function and the point xy is on the graph of f of x, what other point must be on the graph of f of x? Okay. So remember, if we have our little chart, we have x and y. Okay. If we have negative x and we have positive x, then these 2 numbers are going to be the same. Okay. So if we have x and y, what other point is going to be on the graph? You're going to have to do a little bit of thinking there to figure it out, but I believe in you. Okay, let's move on to odd functions. They're symmetric when reflected about the origin. So before we were just going side to side, okay, for even functions. Now we have to go side to side and up and down, okay? So 2 reflections. You go from f of negative x is equal to negative f of x, okay? So if we start out with a negative x, it's going to be equal to a negative y. Remember, f of x can be translated, can be switched with y. You're just allowed to do that, okay? So if the x is negative, then the y is negative on the other side. It works, okay? This should be in your notes. Here's example 1. Algebraically determine if the function f of x is equal to x cubed is odd by calculating whether f of negative x is equal to negative f of x. How we do that is first we're going to substitute negative x in place of x in the function. Okay, so here's our original function. So we have f of negative x, that's what we're dealing with, okay, equals negative x cubed, which is right here. Okay, negative x times negative x becomes positive x, times negative x stays negative x. So it just becomes f of negative x is equal to negative x cubed. Okay, now the next thing we're going to do is we're going to do the opposite one. We're going to do a negative f instead of a negative x. Okay, so now all the f's are negative. So negative f of x equals the whole problem is negative, and then you write the rest of the problem, x cubed. Okay, and that ends up being x times x times x is still x cubed, and the negative drops down, so it ends up being negative f of x is equal to negative x cubed. That means that the 2 answers equal each other. They're both the same. F of negative x and negative f of x are both negative x cubed. That's exactly what we're looking for, so this is an odd function. The table illustrates the reflection across the origin. X of f of x becomes negative x of negative f of x. Remember, we did a lesson about reflecting about the origin, and both numbers change their sign. Examine the values for f of x equals x cubed in the table. So when our x value is 0, our first f of x value, our positive one, is 1. When x is negative, okay, and it's a 2, then our f of negative x becomes a 3. This is all written ski-wampus. I wrote this very crooked, I think. So when x, I think it's supposed to be down this way. This should be x. This should be f of x. This should be negative x. And this should be negative f of negative x. I believe it goes this way. So ignore this. This makes more sense. So when x is 0, f of x is 0. When x is 1, f of x is 1. When x is 2, f of x is 8, because it's 2 times 2 times 2. When x is 3, then f of x is 27. Okay? Then, when negative x is 0, negative f of negative x is 0. When negative x is 1, then negative f of negative x is negative 1. Okay, all of these signs just switched. Positive becomes negative, positive becomes negative, positive becomes negative, positive becomes negative. We did all of this in our origin lesson, so if this isn't making sense, go do a refresher on the origin, reflection about the origins. The values in this table highlight 4 key facts. First, the function is symmetric with respect to the origin. To reflect a point about the origin, negate both the x and y values. Okay, remember this isn't up here, it's down this side. Notice, for example, that f of 1, okay, so this one right here, equals negative 1, okay? F of negative 1 is negative 1. F of 1 is 1. F of negative 1 is negative 1. Both the inputs and outputs have been negated. This pattern holds true for all the values of x. Okay, so we just flipped the sign for all of this stuff. This one should be a negative. I apologize about that. Number 2, negating each input in the function will negate the corresponding output such that f of negative x is equal to negative f of x. For example, f of negative 2 equals negative 8, and negative f of 2 equals negative 8. Okay, you can see that in this column here. This pattern holds true for all the other values of x. A reflection about the origin does not have an effect on the point 0, 0, because zeros are not positive or negative. They just are. For this function, the reflection about the origin reflects points from quadrant 1 to quadrant 3. And we talked about this in our lesson about reflections about the origin. All of these ones are positive, so they're right here in quadrant 1. All of these are negative, so they're right here in quadrant 3. This is example 1. The graph shows how odd functions are symmetric about the origin. The points are in quadrant 1, where the x and y values are both positive, and quadrant 3, where the x and y values are both negative. The curves of the line mirror each other diagonally about the origin. So if I folded my paper this way, these two lines would match up exactly. And that's because we have to reflect both over the x-axis and over the y-axis. We have to do 2 reflections, okay? You could also fold the paper this way and then fold the paper that way, and they would match. Here's a check-in. What is an odd function? A function such that f of negative x is equal to negative f of x. This should be in your notes. Identifying odd functions. They look the same when reflected about the origin. So we talked about this in our last lesson too. If I have that little curved line like this across my graph, okay, one starts at the top and goes to the bottom when your numbers are on the graph, and the other starts at the bottom and goes to the top. There's actually 2 lines, but they hit every single point the same, just in a different order. So it looks like one line. Each point can be reflected about the origin by negating both the x value and the y value. There's our little formula again. F of negative x is equal to negative f of x. Parent functions with odd exponents, such as f of x is equal to x cubed, f of x is equal to x to the 5th, f of x is equal to x to the 7th, are odd functions. However, transformations of these functions do not imply the function will also be odd. So if you mess with this, if you add 2, or if you multiply by 3, whatever, it doesn't necessarily mean that it stays an odd function, but if you have just this formula, it's automatically an odd function. If this is all that you have, is f of x is equal to x raised to an odd number, it's automatically an odd function. You don't have to think anymore. Okay? Example 2, explain why the graph f of x is equal to x plus 1 cubed is not an odd function. So why does this one not work? Okay? It's not an odd function because the graph is not symmetrical about the origin. The points on the opposite sides of the origin are not the same distance from the x-axis. So negative f of 1, which is right here, does not equal f of negative 1. Okay. Oh, sorry, which is right here. I highlighted the wrong one. I apologize. So when f equals negative 1, x is negative 2. And when x is 1, f of x is 8. That you should not see that. These should be 1 and negative 2 and negative 1 and negative 2. Okay? Or 1 and 8 and 1 and 8. These should be able to mirror each other, and they don't. This is further proven when examining the points more closely in a table. The x and negative x values don't have the same y and negative y values. Okay? So if I have negative 2x and positive 2, they should, well, okay. Okay, it says, based on the tables, determine which functions represent an odd function. Okay? So to identify the odd functions, we're going to look, they look the same when they're reflected about the origin. The graph is symmetric with respect to the origin. Each point can be reflected about the origin by negating both the x and y values. Okay, so both the x and y values are going to change. So if we have negative 2, negative 5, we should have positive 2, negative 5. That doesn't hold. Okay, so this should change and this should change. So that one's out. If we have negative, negative, we should have positive, positive, negative, negative, positive, positive. I'm guessing this is supposed to be a 2. I probably typed that wrong. Let's get rid of that. And then zeros don't alter. Okay. 3 and 11, negative, positive. We should have positive, negative. That one's out. Okay. So the only one that's correct is this one, as long as this one is actually a 2, which I'm sure it is because I tend to make mistakes. Okay. All you do is look to see if it should be 42024. 64, 8, 0, 8, 64. The numbers should be the same. Like you have 0 and then you have 8, 8, 64, 64. Okay? And then the signs get flipped appropriately. Here's a check-in. The graph of an odd function looks the same when reflected about what point on the coordinate plane. It's reflected about the origin, which is 0, 0. Here's question 1. Identify which graph shows an even function and which graph shows an odd function. Here's what the graphs look like. Go ahead and pause the video and figure it out. Okay, this one is our even function because it's reflected only across the y-axis. This one is our odd function because it's reflected two ways, both over the x-axis and over the y-axis, or you can say it's reflected about the origin. All right, here is question 2. Identify which function is odd and explain why in terms of reflection. So to do this one, we need to remember that f of negative x is equal to negative f of x. Okay, that's our rule for odd ones. So we're going to take our first formula and we're going to substitute f of negative x in there for it. So f of negative x is equal to, make all of the x's negative, so negative x squared plus 1. A negative times a negative becomes a positive, so we have just x squared plus 1. So the answer for this first one is x squared plus 1. Let's see what happens when we do it for f of negative f of x. So when we have negative f of x, that means the whole problem is going to become negative. So we're going to put a negative and a parenthesis and the whole problem. X squared plus 1, which means this negative needs to get distributed out to everything. Okay? So this becomes negative and this becomes negative. So we have negative x squared minus 1. So does this match this? No. So that means that our first one is not odd. Okay? So our first option has been eliminated. Let's try the second one. We're going to start with f of negative x. So f of negative x is equal to, every x becomes negative, so negative 3 times negative x raised to the 5th power. Okay? So every time that you're raising to an odd number, the negative is going to stay. So this is going to be negative 3 times negative x to the 5th. Okay? Or you can write it as negative x to the 5th, like that. That's another correct way to write it. Okay? So, does this goes up here, we have negative 3 times negative x to the 5th. Okay? Let's figure out the second formula, which is negative f of x. So if we have a negative f, of x, the whole problem is going to become negative. So we have a negative, then a parenthesis, then negative 3x to the 5th. So this negative is going to get distributed to everything. So negative negative becomes a positive. So we have 3x to the 5th. So does this formula match this formula? The answer is no. Okay. Oh, wait, I did something wrong here, though, because look, negative times a negative becomes a positive. So it's 3x to the 5th. I am a math genius. So is 3x to the 5th equal to 3x to the 5th? Yes. So this one is our winner. Now, I'm going to double check this last one because that's what you should do when you struggle with math as much as I do. If you don't want to sit and do that, that's fine. Skip to the next slide. But if we have f of negative x, all the x's are going to become negative, is equal to 2 times negative x plus 3, which then equals negative 2x plus 3. Okay, so let's put that formula up here. Negative 2x plus 3. Let's do the next one. Okay, and now we're going to do negative f of x, which means the whole problem is going to become negative. So negative 2x plus 3. The negative gets distributed to everything in the parentheses, which now means we have negative 2x minus 3. Does this formula match this one? No. So our correct answer is that middle one. When negative x is substituted into f of x, the sign of the function's y value changes the graph so that it reflects about the origin. The points on the graph would be at equal and corresponding distances from the x-axis on both sides of the coordinate plane, which are all requirements to make this an odd function. And this just shows the math that you go through to make it match up. Okay? Practice question number 4 at the very end of your lesson. Sketch the graphs of f of x equals 5x to the 5th minus 3x and g of x equals negative f of negative x. Based on the graphs, is f of x an even function, an odd function, or neither even nor odd? We're going to go to GeoGebra. We are on GeoGebra.com. Let's go ahead and enter our formula. That's not what it's called, but I'm tired. So we have f of x is equal to 5x raised to the 5th power. Let me see how I do that. I can do this. Nope. 5th. Okay. Minus 3x. Okay, so here is our first one. And then it wants us to also graph its opposite, which is g of x equals negative f of negative x. Well, guess what? There's no need to do that because it's going to be the exact same. It's just drawn from the opposite direction. So looking at this, we need to determine, is it even, is it odd, or is it neither? Decide and come back. Well, if the graph is anything that looks like this, Is it even? No, because it went across, it reflected twice. It went sideways and up and down. So what does that mean? It either has to be odd or neither. And I did not stop to go and check all of my points to see if it was odd or not, so I better go do that. If you go to GeoGebra, there's actually like a point here and a point here that you can click on that are like not on nice pretty lines. And yes, it is an odd function. They do match. So it's an odd function. It's option number 2. Okay, here's practice question number 5. The graph of f of x looks the same when it is reflected about the origin. Is f of x an even function, an odd function, or neither an even nor an odd function? This is speed round. Decide! It's an odd function. If it looks the same, if all the points line up, then it's an odd function. Okay. Quick check question number 4. Identify the odd function. So the way you do this is, again, our formula is f of negative x is equal to negative f of x. So you're going to take your formula, for example, this one, and you would start with f of negative x. And this means you're going to make all the x's negative. So it would be 2 times negative x plus 1 cubed, and go through and solve it, and then see if that answer matches it when you put in for negative f of x. Okay, we did this together. You should be able to do this. And this is quick check question 4. And then quick check question 5 is which table shows an odd function. Now remember, odd functions mean that you should have repeating numbers and that the signs should be flipped. Okay? If you need to go back and review that, go back and review that. Liebet makes the world go round.